Ever wondered how to get started with Arduino? Wonder no more, because today we're diving into the basics of this fascinating tool. Arduino has utterly transformed the do-it-yourself electronics landscape, empowering anyone to create and innovate. From simple hobby projects to complex robotic systems, Arduino has been the game changer in making electronics accessible to all, so buckle up as we embark on this electrifying journey. By the end of this video, you'll have a solid foundation to start your own Arduino projects. So, first things first, what exactly is Arduino? Well, to put it simply, Arduino is a powerful tool that opens up the world of electronics to everyone, from hobbyists to professionals. It's a hardware and software platform, a combination of a physical programmable circuit board and the software used to program it. Now, you might be wondering, what sets Arduino apart? The answer lies in its open source nature. Open source means that its design is publicly accessible. Anyone can study, modify, distribute, make, and sell the design or hardware based on that design. This openness encourages a community of creators to contribute and improve upon the platform, making it a hub of innovation and creativity. The real beauty of Arduino lies in its versatility. It can be used to create interactive electronic objects, from simple LED light displays to complex robotics. Whether you're looking to create a weather monitoring system, a home automation device, or even a musical instrument, Arduino provides the foundation for your ideas. Additionally, Arduino is designed to be as user-friendly as possible. It doesn't matter if you're a seasoned programmer or a complete novice, Arduino's intuitive interface and supportive community make the process of creating electronic projects accessible and enjoyable. In essence, Arduino is the gateway to bringing your electronic ideas to life. Now that we've established what Arduino is, it's time to delve into the hardware. The Arduino board might look intimidating at first glance, with its array of pins and components, but fear not. Once you understand the layout and function of each part, it all starts to make sense. Let's start with the heart of the board, the microcontroller. This is the brain of your Arduino, where all your programs or sketches run. It processes the instructions you give it and interacts with other components on the board to bring your projects to life. Next, we have the digital pins, a line of connectors on the board. These pins can read or write digital signals, meaning they can be either on or off. You'll use these to connect various components like LEDs, buttons, and even other microcontrollers. Following the digital pins, we have the analog pins. Unlike digital pins that understand only on or off states, analog pins can read varying degrees of input. They are handy when dealing with components that produce a range of outputs, such as temperature sensors or light sensors. Lastly, but certainly not least, we have the power pins. These are your Arduino's lifelines. They provide power to the board and other components. Among these pins, you'll find the 5V pin that provides 5 volts of power, the 3V pin supplying 3.3 volts, and the ground pin, which is used to complete circuits. It's also worth mentioning the USB interface, which is not just for powering your Arduino, but also for uploading the code from your computer. Remember, the key to becoming adept with Arduino is understanding each component and how they interact. It's like learning a new language. And just like any language, practice makes perfect. Getting to know your Arduino hardware is the first step towards mastering it. With the hardware out of the way, let's turn our attention to the software side of things. Now, to breathe life into our Arduino, we need software to control its hardware. But what software, you ask? Enter the Arduino Integrated Development Environment, or IDE for short. This is the platform where we write and upload code to our Arduino board. The IDE is a user-friendly software designed with beginners in mind. It's available for free download on the Arduino website, compatible with Windows, Mac, and Linux. The IDE provides you with everything you need to write, compile, and upload your code to the Arduino board, It's the cockpit from where we pilot our Arduino projects. But what language does Arduino speak? It's a blend of C and C++, two of the most popular programming languages in the world. These languages are widely used due to their flexibility and efficiency. If you've ever dabbled in programming before, you may find some familiar syntax. But if not, don't worry. The language is simple, and with practice, you'll pick it up quickly. So, let's dive into the structure of an Arduino program. An Arduino program is called a sketch. A sketch has two primary functions, setup and loop. The setup function runs once when the program starts. It's where you initialize variables, pin modes, or libraries. The loop function, on the other hand, runs continuously after the setup. This is where the main logic of your program resides, controlling the Arduino's behavior. Now imagine this. Your Arduino board is like an orchestra, and your sketch is the conductor. With the right commands, the conductor can make the orchestra play a symphony. Similarly, with the right commands in your sketch, you can make your Arduino do just about anything. From blinking an LED to controlling a robot, the possibilities are endless. And that's the beauty of Arduino. It's simple yet powerful, making it a perfect tool for both beginners and seasoned makers. So, roll up your sleeves, download the Arduino IDE, and start creating. With the right commands, you can make your Arduino do just about anything. Now that we've covered the basics, it's time to put this knowledge into action. Let's start with a simple yet exciting Arduino project, making an LED blink. This is like the hello world of the physical computing world. It's simple, yet it will give you a great sense of accomplishment when you see that little light flicker on and off. First, we'll need to write the code. But don't worry, Arduino uses a simplified version of C++, making it beginner-friendly. We'll start by defining the LED pin, which is where you've connected your LED on the Arduino board. For this example, let's assume it's pin 13. Next, we'll set up the void setup function. This function runs once when you power up your board or hit the reset button. Here we'll define the pin mode for our LED pin as output. Moving on to the void loop function, this is where the magic happens. This function runs over and over again, creating our blink effect. We'll turn the LED on with a digital write command, wait for a second with the delay function, then turn it off again and wait for another second. Once your code is ready, it's time to upload it to the Arduino. Connect your Arduino board to your computer using a USB cable. Go to Tools, then Board, and select your Arduino model. Next, go to Tools again, then Port, and select the port that your Arduino is connected to. Now, hit the upload button, and there you have it. If you followed these steps correctly, you should now see your LED blinking on and off every second. This might seem like a small step, but trust me, it's a giant leap in your Arduino journey. You've just interacted with the physical world using code. How cool is that? And just like that, you've created your first Arduino project. Congratulations! We've covered quite a lot today, haven't we? We've journeyed through the intriguing world of Arduino, and I hope you've enjoyed it as much as I have. We started by unraveling the mystery of what Arduino is. We discovered that it's an open-source electronics platform that's both user-friendly and affordable, making it a favorite among hobbyists, students, and professionals alike. We learned that its flexibility allows it to interact with a wide variety of inputs, from buttons and pressure plates to light and humidity sensors. Next, we delved into the hardware of Arduino. We examined its different components, from the microcontroller at its heart to the power jack, the USB connection, and the digital and analog pins. We touched upon the importance of each component and how they all come together to make the magic of Arduino possible. Then, we explored the software side of things, immersing ourselves in the Arduino IDE. We discussed how it's used to write and upload code to the Arduino board. We also looked at the structure of Arduino code, highlighting the importance of the setup and loop functions and how they control the behavior of the board. Moving forward, we took our first steps into creating an Arduino project. We walked through the process, from connecting the components on the breadboard to writing and uploading the code. We even created a simple LED blink project, a classic first step for any Arduino enthusiast. Now, as we wrap up, I encourage you to take these basics and explore more complex projects. Dive deeper into the sea of possibilities that Arduino offers. Experiment with different components, try out new codes, and don't be afraid to make mistakes. It's all part of the learning process. Remember, the only limit to what you can achieve with Arduino is your imagination. So go forth and create.